Okay, so here we have the symbol for a capacitor. Now, a capacitor has a pretty important role in your preamp circuit because the capacitor actually allows you to control what frequencies um, you're going to have present in your guitar tone. Okay, so that is one of the properties of capacitors that make them really valuable to tube amplifiers. There's another property of capacitors that are very very helpful for tube amplifiers, which we'll get to later and when we talk to power supplies, because capacitors help us to filter away noise when we get it when we plug in our amp to the wall. But what we're going to focus on is the power that a capacitor has to filter out certain frequencies that you may not want in your tone. So this is the symbol of a capacitor. Now, a capacitor is when you have two two metal surfaces that are separated usually by some fluid that doesn't allow the conduction of electricity. So it could be fluid, it could be air. So you can have a signal going through one plate and you have another plate running parallel to it. That's going to be a capacitor. Okay, so capacitors come in many different shapes and sizes. So here are a few different capacitors so you can see what they look like in the wild. Most of the time in guitar circuits or bass circuits, you're going to see capacitors that look like this. Okay, in amps, typically that are going to be hand wired, you're going to see capacitors that look like this and this. Okay, these capacitors here are electrolytic capacitors, which are allow you to store a lot more charge. That's what capacitors do. They store and discharge energy, kind of like batteries. Capacitors that store a lot more energy are called electrolytic capacitors and look like this. But what we're going to focus on today are we're going to focus on capacitors that are bipolar. Okay, so electrolytic capacitors. Electrolytic capacitors have a positive end and a negative end. So we're going to focus on capacitors that you don't have to watch the orientation of. So those would be these capacitors here, 1, 2, and 3. Okay, so how exactly do they help us in a tone circuit? Well, the thing to know about a capacitor is that a capacitor blocks low frequency content. So a capacitor blocks bass frequencies and lets treble frequencies pass. Okay, there are equations to let you know what frequency a capacitor will start to block signal at. But for right now, we're just going to talk about bass frequencies and treble frequencies. Okay. So what we're going to do is we're going to take a look at the wiring diagram for the tone circuit in the Telecaster, and then we're going to take a look at the schematic to see how the tone circuit works. So if you take a look, we're going to get a feed from our pickup. Okay, that's going to be our signal coming from our guitar or bass, and then that's going to go into this potentiometer. So it's going to go through a certain amount of resistance, which is going to be set by your tone control. Okay, so it's either going to go through a lot of resistance or no resistance based on where you have that knob. Okay, and then that signal is going to go through a capacitor and then hit ground. Okay, so the thing to know about ground is that it's 0 volts, right? So once your signal goes through there, it's almost like it's getting flushed down the toilet. Once the signal goes to ground, it's not possible for it to come out of there to make it to your output jack. Okay, so the thing to note is that, again, capacitors, they allow treble frequencies to pass through while they give a lot of opposition and resistance to bass frequencies. So if you think about it, we're coming along from your guitar pickup. we're going into your tone control. Based on where your knob is set, you're going to have a certain amount of resistance, okay? And then it's going to pass through this capacitor. But all of your bass frequencies are being blocked, okay? So the treble frequencies come along, go through this resistor. If it's a treble frequency, it's actually going to go through this cap and go to ground. So your tone control, what it does, it doesn't increase the amount of treble. It actually controls how much treble you are allowing it to bleed to ground and not be heard into your signal. So your tone control is really a treble roll off more than adding any treble frequencies to your guitar signal. Now let's show you the schematic for your tone control, okay? Okay, so we'll zoom in over here. Okay, so here we have your pickup. We're coming out of the pickup. First, the signal from this point goes through your volume control, right? Based on where the wiper is, it's gonna go pick up a variable amount of resistance from your volume knob and then go to the output. From that same point, your pickup is going to send this signal through a fixed or amount of resistance that's determined by your tone knob. And then if it has enough treble content, it'll go through this capacitor, okay? But if not, if the frequency is too low, then it gets bounced off of this treble. It gets bounced off of this capacitor, and it'll just go through the path of going through the volume knob into your output, okay? So this, as I mentioned, this is the symbol for a capacitor. Capacitors get measured in a unit called farads. The unit of a farad measures how much energy you can store in a capacitor, which is going to be pretty crucial down the line when we talk about power supplies. The thing to note about capacitors is the smaller a capacitor is, the smaller the passageway is for bass frequency. So the smaller a capacitor is, the harder it is for bass frequencies to pass through, okay? So that's one thing to note about the capacitor and how it works. Now, if we take a look, if we just if we take this pickup and we just delete this, one thing that you'll note is that the schematic for a volume and tone control in a Telecaster is very, very similar to the preamp in Fender Princeton, and we're talking about the Fender Tweed Princeton, the 5F2A. So we're going to pull up a schematic of that quickly, just so we can take a look at what that looks like. So let me go ahead and do that. I'll pull up. Okay, so what we're going to do, we're going to zoom in on just the EQ portion of this. We're going to pull in on just the EQ portion of this schematic, okay, which is going to be right here. So here, so we're going to look at this from here. Actually, I have a better picture of this that's zoomed in. Here we go. Okay. So here you have your guitar signal coming in, and it goes to a volume pot. Looks very familiar, right? You have your variable resistor here. You have your wiper here where your signal is going to come out of after going through a resistance that's set by your knob. It's the same schematic as the volume knob. Okay, now from that same point, it goes into a tone control. Okay, it goes into another variable resistor which sets how much resistance your signal is going to go through. Again, here we have a capacitor that's only going to allow your treble frequencies to go to ground. Okay. So there are two things that are actually happening here. Okay. So one, some of your larger, as I said before, the smaller your capacitor is, the harder it is for bass frequencies to go through. Okay, so what's going to happen is your signal is going to come in from your guitar, and the highest frequencies are actually going to go through this path and get steered around the volume control, and we'll be able to avoid this volume control and make it to the output of your preamp. So some of the lower treble frequencies are going to go through this wiper, and they'll be able to pass through this capacitor and go to ground. Okay. Now, all of your bass frequencies will see both of these capacitors, and they're going to be blocked from following this path. They're going to have to go through the volume pot. Since they're going to have to go through this resistor, what will happen is those bass frequencies will be decreased in their volume compared to the treble frequencies. Those treble frequencies, especially the highest ones, will come through this wiper, and they're going to go through this capacitor and avoid this volume pot. Well, thank y'all for taking a look at this video on resistors, capacitors, and preamps and tube amps. Just taking a look at the volume and tone control in your guitar. So next, I will probably do a video on how tubes work, and how they serve as the active devices we need to make your signal louder. Here we've only looked at passive devices that cut down on the voltage of your guitar signal and the volume of your guitar signal. So we'll talk about tubes, which will actually make your signal louder next time. All right, take care. Peace. We do this for the culture.